They just made ArXiv for AI written papers. This is crazy idea. So it's a server where AIs, different AI agents, groups, laboratories, but only AIs can write and publish papers, and then they can look at papers of other AIs and improve on them. So human researchers can provide initial guidance or research directions, but I believe you can also make this without any human research guidance. And then agents autonomously perform research and upload research papers to the centralized agent archive preprint server. So you have these agent AI automated agent laboratories all around the world, and they all publish papers, and then they work off of each other papers and learn from each other just like humans. Help me bring free AI education full-time. Progress in scientific discovery rarely results like from a single eureka moment, but it's a long and mundane process of collaborative research of many scientists. There is a very nice saying I say, excellence is mundane. It's a very slow, incremental step-by-step improvement process, like everything else. And while today there are AI research scientists that are fully automated, they just do one research and that's it. They don't have this ability to iteratively improve on each other's work step by step. So here, this is the graph of progress. So this is GPT-4o mini on this Math 500 benchmark, starting from the first paper that was written by this autonomous laboratory. It improves a little bit. Or no, this is the baseline, sorry. And then the second paper improves a little bit, a little bit, a little bit. Every time this autonomous laboratory writes a paper, there is a slight improvement. And at the end, there is a 7% improvement in total. So GPT-4o mini even beats GPT-4o with chain of thought, just with this technique of writing papers and discovering, which is actually crazy interesting. And GPT-4o mini base is just 70% accurate, and even the first paper that was written, it increased the accuracy over the base model. And so this latest method, simultaneous divergence averaging, they want to test if it's going to work, even if they apply to other benchmarks, not just this Math 500 that it was built for. And they find out that even on difficult benchmarks like GPQA, it gets 6.8% improvement, which is a lot. And MMLU Pro, 12% improvement. And other benchmarks around 8 to 11% improvement. Which also includes this medical QA, which is not so much mathematics reasoning. So you can see the same thing here. You have zero-shot prompting, and you have this AI-discovered method, and you see that on each of these, it gets improvement of a few percent to 8% in accuracy. It's also interesting. The pink line shows generated papers, but without those papers did not reference and learn from any other papers that are AI generated from before. And the green line shows accuracy if the AI generated papers learned from papers that were generated before with AI as well. And there is a big accuracy improvement around 5% or 4.5 to 5%. And this is actually the most interesting part. By now, we have different models. So GPT-4o Mini, 4o DeepSeek V3, and Gemini 1.5 Pro and 2.0 Flash. And for each model, it looks like every single model got improvement or is equal. So we see here that the blue line is always higher than this same shape gray line. Except here. So maybe this algorithm is not good for GPQA for some models, for example. But we can see that this algorithm is really good for these other types of benchmarks. To retrieve papers, they use just vector embedding RAG. So they encode the existing paper with a vector, and they encode the search query of the agent laboratory with a vector, and they do a cosine similarity and that's how they retrieve. Average cost per paper is $3.11, with the most expensive one being almost 10 and the cheapest one being 2.15. This is less expensive than O1 Mini, which is around $7.50, and O1 Preview, which is around $13 per paper. On average, one paper took 1.36 hours to generate, with the longest paper taking 11.9 hours and the shortest one taking about, how much is this? 5 minutes, I think. And they evaluated performance on 500 test problems, which is considerably more than previous studies. So they had 3 labs, AI labs, run in parallel, and each of them produced 40 papers. And so the times to produce were 57.3 hours, 64 and 42 hours, respectively. And the total cost was $87, $94, and $98, summing up to $279.6. Their first objective was to establish whether agents can build on top of their own research. So they began with running a single agentic system to generate 40 papers using O3 Mini Medium. Also, while generating each paper, they were allowed to look at 5 papers that they searched for from the papers that they previously generated, and 5 papers from ArXiv that were human written. So I guess this was I didn't I don't see if this is specified, but in the first 5 generations, when there is no 5 papers previously generated, I guess they just looked at whatever they had. And also they did not give it direct idea to work on, they just gave it a research direction, but the AI can come up with its own ideas. For example, the direction was improve accuracy on Math 500 using reasoning and prompt engineering. And so it's going to use GPT-4o Mini to prompt engineer this guy to improve accuracy, but the thinking model is O3 Mini Medium, and it's trying to improve prompt for GPT-4o Mini. And as you can see, I already showed, but with each generated paper, the performance was improving. The setup was also a bit confusing to me, so there are 2 distinct experimental setups described in the paper. Setup 1, sequential. So there is only one agent laboratory system running. It runs its first research cycle and produces paper 1. Paper 1 is uploaded to Agent ArXiv. The same single lab then starts its second research cycle. During the literature review of cycle 2, it searches Agent ArXiv. What does it find? Only paper 1. So then it's gonna write a second paper based on this paper to improve towards the set research direction. And then in the next cycle, it's gonna look at paper 1 and paper 2, and so on for 40 cycles. But first of all, it also looks into human written archive, and it's limited to maximum 5 papers from both of the archives, the AI agent archive and human archive. So at any point in the sequential run, Agent ArXiv only contains papers generated previously by that single specific lab. This is in the sequential run. So basically here just one laboratory is publishing papers onto this server, and this question is checking if one laboratory can improve its research over time. And the answer is yes, it can. So in the second parallel setup, you just have 3 of these laboratories, and they all add their papers into the agent archive, and then in the following cycles they can look at papers from each other. And they also it says that the setup is same as in sequential, so that means that they also can look at top 5 papers from this agent archive and top 5 papers from human archive. So the results: The sequential lab produces 40 papers and achieves 78.2% accuracy, which is 11.4% improvement over baseline. And its final technique is this SDA technique. So this shows the comparison of the results. So we have 6 lines, 3 lines are colored and 3 lines are gray. The colored lines share papers between each other, so this is the parallel setup where the 3 labs produce papers and they look at each other papers, and one of the colored lines achieves highest accuracy. And 3 gray lines are sequential setup, so each gray line only looks at its own papers it's produced. And so they run it 3 times, so it's fair, they use same amount of resources. And we can see that the 3 labs that work together, one of them produced the highest scoring method, which is good because, for example, here, yeah, it just won. But the drawback is it used 3 times more resources to produce it because you need to run 3 in parallel than any of these gray lines, because they just use a third of the resources to produce a few percentage less results. So I wonder what the implications of this are. Maybe if we get better reasoning AI, these results would improve, and then what are implications of there? When can we just start using this multi-agent, multi-laboratory research setup? Help me continue doing these AI research papers full-time by supporting me on Patreon. See you next video.